to quickly look at the setup for Practical 4, question 2. What you can see there is I've connected a D latch and I've connected a D flip-flop, both to a signal generator. I guess you can see that there. The signal generator is going at 1 Hertz, and then what I have is 2 buttons here, and these buttons drive the enable of the latch and the clock input of the flip-flop, and they're both just connected to a resistor that pulls it down to ground, and then to make it high you push the button, you push the switch. If you didn't have that, there's a chance for this thing to float. So the purpose of this resistor is to pull it down to ground unless you're pressing the button, which pulls it up to 5. Very similar to the gate switches and the transistors. So on the output here I've just put an LED to indicate which one is on or when they're on, with a resistor to limit the current, and then I've also put the signal generator output on an LED. In the circuit I'm about to show you, this LED is yellow and this one is red and this one is red as well. So if I go to my circuit, what you can see here is, I'm just going to get something to point with. What you can see here is this LED is the signal generator going high, low, high, low, high, low at 1 Hertz. And if I point you towards the signal generator, this is actually quite important to get. Just give me a sec, I've got X flipped around. This is quite important to understand as well, so I'll quickly show you how to set it up. What you need to do is first of all select a square waveform, so press wave and then select square by changing this knob, rotating the knob. Then you select the frequency and yet again you rotate that all the way down until you get 1 Hertz. Right, so it's going at some frequency at the moment. Let's just make it 1 Hertz. 1 Hertz, enter, there we go. So it's going at 1 Hertz now, and if you look at this LED, it's flashing at 1 Hertz. But before you connect it up, you need to just be sure that your amplitude is set to 5 volts. That needs to be 5 volts, that's an imperative. And then your duty cycle, you can set that to 50% is good. Then it flashes for the same duration than what it's on. So be sure your duty cycle is 50%. So half of the time it's on, half of the time it's off. And you can play around with that to see how your LED flashes differently. And then the important one to get right is also your offset. Now your offset you need to set to 100%. If you have it at 0%, your signal will vary between minus 2.5 volt and 2 volts. So that could actually damage your electronics. So you want that DC offset to be set to 100%. So you choose a square wave, 1 Hertz, amplitude of 5 volts, duty cycle 50%, and an offset of 100%. And when you've done that, you can now see here. This is where the signal generator signal comes in, and as soon as it comes in, I just take it through an LED and then through a resistor down to ground so that it flashes. What I then is on the top here I have my flip-flop, and over here I have my latch. So it gets power, latch negative, so 0. And then what I also have is this push button set up here. And this push button goes to the clock enable, or the enable of that latch. And what I have then is at the input, you can see this wire here, that is the input that comes from the signal generator. That goes into pin 2, which is one of the flip-flops. I'll quickly show you that, if I still have it open. Yeah, I do. There we go. Pin 2, it's just D0, so that's fed through onto Q0. So I'm feeding that input into my latch, and then at the output I'm just taking it through a resistor, through an LED, and then to ground. By the way, the order of the resistor and the LED don't matter, it's serial, so the current is constant through them regardless of which order you connect them on. It doesn't matter. So what I have then is this input from the signal generator going into a latch, and then I'm also feeding it through. So that signal from the signal generator also going into the flip-flop, the 157, is it? The 175 IC here and the 583 here. So this flip-flop gets the same input into its queue. You can see it's pin 4, and if I just open here, you can see pin 4 is D0 on the 175. So I'm expecting an output on Q0, which is pin 3, and that's exactly the output that I'm taking from pin 3 here. I'm actually using pin 2 for some reason. Oh, sorry, it's pin 2. Q0 is on pin 2, and that brings me through the LED, through the resistor, down to ground. So I'm measuring the output of both Q0 for the latch and for the flip-flop. I'm giving it as a D. I'm giving it this 1 Hz signal, and now I want to demonstrate the difference between the two. So a latch is level sensitive. So all it does is, if I press my enable in, which really connects it to 5 volts, so if I have that clock enable as positive, it literally just follows it. It's just a follower. As soon as I disconnect it, it remembers its last state. I'm going to leave it at 0 now. It just remembers its last state and then continues forward. So that's your latch. While clock enable is 1, it follows the input, it follows D, and when you leave it, it just stays where it was when you left it. However, for the flip-flop, it works a bit differently. For the flip-flop, it does a sample every time you press the button. Not while you press the button, but at that instant of pressing the button, you have a rising clock edge. So I'm going to sample it at 0 now. So it's 0, and you can see I just sampled a 0. I'm going to sample it at 1, sample and 1. If I keep it in, what does it do? Well, it just ignores this pressing in because it's not level sensitive, it's edge sensitive. So the action happens at that instant of pressing the button. Can you see that? So I'm going to press it when it's 1 again. Ah, I just missed it. There we go. And that is the difference between a flip-flop and a latch. And that's what I want you to build for question 2. I just want to quickly warn you, or at least explain to you why we're doing that switch thing. If I were to remove this input and do that, what you will see is, by me just tapping on this, I'm causing that clock edge. I'm causing it to trigger, and the reason is because this input of mine is floating. You can see by just doing that, I'm causing it to go into a clock event. So that input, that clock input, is floating. Or rather, let me put it differently. Yes, that clock input is floating, which causes trigger events to occur. I'm going to do the same thing with this button. I'm just disconnecting the there we go, just disconnecting that pin, and now you can see I'm causing this clock enable to do things, right? It's actually going with the flow. So in this case, it's just hanging high until I press there. You can see it's extremely sensitive to noise. If you just come close to it, it's starting to act upon it. So that's why we have this. You have to ground your inputs or make it high, and that's why we have this pull down resistor to force it to low when I don't press the button, which again forces it high.